would start in the chat. Okay, so hello everyone. We're gonna review the chapter 11. Sorry, I didn't update the name. It used to be called Choosing the Right Server for You. Now it's called Server Resources and Scaling. So for our learning objectives, we will appreciate computation, hardware, and software. I guess we already do. We're gonna review what are the differences between CPUs and GPUs and RAM versus storage. And I'll show you. Like the parallel thing with a project that I'm doing so that we can check like how do they look in the htop command. Okay, so I mean we all know that everything that we do in our computers um, it ended being converted into ones and zeros. So yeah, everything is represented by a number. And what the computer does is just add things together. And it's like I don't know, for me it's amazing how we can do things at such a high level and never think about what is going on at the hardware level, at the microprocessors level. Like some yes, some of us uh, we don't even know how the memory actually works. I mean, I kind of do, and I'm not sure we all kind of do, but yeah, you don't have to know that part to be able to write software, and that's honestly that's amazing. Okay, so modern computers add very quickly and very accurately, and the speed limit and the speed is limited by the number of cores that a computer has and its clock. So the CPU, it's kind of like the main brain of our computer. It stands for Central Processing Unit, and every CPU has a set of cores, a specific set of cores. And they usually go from 4 to 32 for like personal computers. I don't know if you remember when the first Intel computers launched, when they were like the dual core Intels. That was like such a big thing, but that was like many years ago. And the book says that again, many years ago, the clock speed used to be like a thing, and people will try to yeah, like just change the clock speeds for for the machines to make them go faster. And yeah, I don't know if you ever saw like those images of people like pull like putting some like things for cooling and everything, like just making some weird stuff to their CPUs to prevent them for like getting a lot of heat, and that was kind of like associated with the clock speed. So the clocks now go from 2 to 5 gig. No, what gigahertz? Yes, gigahertz. And that gives us 2 to 5 billion operations per second. So the like that thing of trying to make the clock go faster kind of stopped during the 2010s, the book says. So now our improvements in the computational speed comes from a result of the number of cores and the core usage, and not actually like from the clocks.
Can I
Mm,
ask a couple questions
yeah.
about CPUs that are maybe not related to server stuff, but just for my own understanding? When you say like cores, is there like a physical, like obviously that's like a physical way the CPU, the chip is split up, but like, I don't know, is there any, like, I'm imagining just like are they like physically isolated little cores, like all lined up uh in like a on the wafer, the like square?
Yes, I guess they're supposed to be. I don't think I've ever like actually seen like the chip, and I'm not sure like if they have like different slots for each of the cores. I also know that you can have like real cores and virtual cores, and I don't know how that works, but yeah, I don't know if anyone else can like add something.
Yeah, I have no idea. I kind of make the same assumption as you, Diana, but I don't know.
Uh, Great, thank you. And related question, I think CPUs are only available in like the power scale of like 4, 8, 16, 32, because you're just like taking a square and you're like partitioning it equally into
Yeah.
little smaller squares. Is that like that's correct? As far as everyone understands? Okay.
Yes, I guess I think so. Uh, yeah, right? Because like, yeah, mine has 12.
Oh, okay. So it's not just like a
Yeah,
sequence of 2 to the power of 2.
no. But again,
Weird.
I'm not
Okay.
sure if all of them are maybe 8 real cores and then
Physical
rest
cores
virtual or like
for
something
virtual.
like that. Yeah,
Okay.
I don't, but yeah, that's a good question.
If I
Yeah.
can ask one related question about cores, and I think this is all my like core uncertainty wrapped up. The book doesn't touch on like a physical versus a virtual core, which I guess it doesn't really need to. But so far for my work, like the difference has not been super important. Like, does anyone have, I don't know, stories where like the difference really mattered? Or like, is a virtual core just as good as a physical core? Just wondering if anyone has any thoughts like related to that and their work as data analysts, scientists, more generally.
Uh,
I've not, mainly because like as the book points out, and this has been my experience too, is that R and Python or at least R is single threaded, so it's only hitting one core anyway.
Mhm.
So I've not really noticed a difference. The only differences I've noticed is, if I shift from like tidyverse data wrangling functions to, like data table or data table backed data wrangling functions, I notice a big difference. But I've not seen anything where, I mean, I guess there's like the parallel futures and parallel packages that
Yeah.
kind of try to create chunks and then send them off to cores, but I've not used those yet.
mm. So, like just by making a super quick Google search, so it says that uh you can have 8 virtual cores per real core. So if you do something that's called hyperthreading, uh
Okay. I've heard of that. I don't really know what it means, but I guess it's like beyond what we're trying to talk about today, but
yes,
definitely like a big question mark in my brain.
yeah, 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 actually, yeah, for me too,
And for,
and
and for GPUs, which is coming up, because I always see like that difference, and there are just so many differences between GPUs, and it's always unclear to me whether they're real differences or just marketing differences.
yeah.
Gotcha. Gotcha.
Mm, okay, so as Artem mentioned, usually R and Python are like they only they only have one core. So the book is talking about like when you have to set up an environment for multiple users. So it says, okay, if you're gonna have to use that, sorry, if you're gonna have to have multiple users in a single server, you you should have at least one core per user and an extra core, just because like the computer might like need to do some things by itself, that like some not like non-associated user task, and then like it can use the extra core that is just like there. But yeah, like when we use parallel processing, and like I've used uh MCL applies, and that comes from the package parallel MCL apply. Mm, and like I really like them. I think this is a no way to do parallel programming in R, and I've never used futures, but yeah, if you have a task that you can, like as Arthur said, just divided it into multiple chunks, then you can use these functions that are like the syntax is completely similar to L applied and to M applies, and then you can just like parallelize those tasks, and they work great. mm, but yeah, so
Is
usually
there any like overhead penalty for doing that? Because I feel like there must be like a planning phase. I would imagine like there'd be some workloads for which it'd be cheaper or like sorry, faster and more efficient to just single thread it. And then there's some threshold after which probably you're better if you multi-thread it. Is that has been your experience?
Yes, yes, yeah, no, exactly. Yes. Like for starters, you're bound to the number of cores that your computer has, or the computer that you're working. If you try to go over than that, like it doesn't make any sense. Because the computer won't have cores to actually work. And then like your task has to be like planned, and yeah, think to be able to do chunks separately, and the chunks should, like the tasks for each chunk, they should finish like at at similar rates, because then like when you're gonna like gather all of the results from the different tasks, you don't want like one super slow task and then all of the other threads will need to wait until that one is done to be able to actually finish. So yeah, you can only do that for some very specific task. And yeah, like it wouldn't, like it has to make sense. I don't know if that
The
answered
only
you.
thing I have from my experience to speak of is sometimes when I'm trying to parallelize with like Futureverse, moving the data from, I guess my data lives on RAM, but it's being accessed through my like main single thread CPU. Moving that data, or like I guess making it available to other threads or cores, is I think costly and can offset the performance benefits of using parallelization in the first place. Uh, I've run into that a little bit. I don't really have any good way of knowing, like short of doing more sophisticated benchmarking, of knowing which, like when it's a net positive or negative.
Yeah, yeah, no, no, me neither. Like, mm, yeah, you usually see the performance improving, but I guess like you, yeah, like as Arthur said, you reach a point where you just can't do better because of those like input output operations, or because yeah, like one trend might be slower, or because like that's the best you can do. Mm, okay, so yeah, that's the CPUs. And then we go to memory. Okay, so we have like two types of memory, the random access memory and then the actual memory. So random access memory is a short-term memory. When a process ends, it is destroyed. Like when we turn off our computers, the RAM kind of gets cleaned out. And the recommendation, like that the book has, it's like get a computer with lots of RAM. RAM, I think RAM it's still, I mean, it's not cheap. Like going from 36 gigabytes of RAM to 64, like it actually increased the price, especially for laptops. But well, like yeah, you usually will have you usually will get you will want to have a higher RAM. Mm, it says that again for multi-user, yeah, for multi-user servers, you need to kind of know beforehand like what's the type of data that your users will need, because like what R and Python does is that they will load all your data into your RAM. So yeah, it says the maximum of data times three, and if it is too big, then you can use a disk and then use some of the tools that will be like that. I guess what those tools do is that they do all of the input output operations, but then they have some way of like kind of making it seem like everything is in RAM, but it's actually not. And I haven't used Arrow. I don't know, but like I've heard that it's great, and I know that a lot of people use it. I don't know if you use it before. If someone has some experience with Arrow.
I've never used it. I'd be very eager to hear about, someone's usage of it. Because like you, Diane, I've heard really good stuff. Yeah, like Parquet files, they seem really appealing.
Yeah.
The only thing I know about Arrow that I've used it for is I think a thing that's called sharding, like to shatter, like to shard, where you take a big database and you define variables. So say like country and year in an imaginary data set. Through like the R code that you write using the Arrow package, it would write that file into smaller files for each combination of country and year, so that you could then like read in only the countries and years you want.
Mm.
But I don't know if like you still have to, I think, be able to load all the data initially into your computer to shard it and then move it to maybe somewhere where people with less performant computers can access it kind of piecemeal like that.
Okay. Okay. Yeah. Yeah. If you don't have, yes, if like if you don't have it in chunks, like from the beginning, you will have to like load everything and then do that. Okay. Yeah, and I guess like that, I mean, it depends on what you're doing and the type of data that you're working with. Like for many people, like that won't be a problem. If you're only working with small files, then like it's fine, and you might never run into one of these problems. Okay. And that was random access memory, and we also have our physical disk, and that's the storage. They're usually bigger and better and cheaper. Mm, oh, I guess Arthur Python. Oh, sorry. Okay. Arthur said that Python may become multi-threaded. Okay. By like by its like from its core.
I'm not sure on the details. So I think there's this project called Mojo, which is I think an effort to make Python more performant. I'm not sure what level it's done, but I think one claim is it's gonna like parallelize work. I'm not sure how or if what the user is gonna have to be concerned about it. But yeah, I think Mojo is closed sourced right now, but eventually will be open source in future.
Okay,
So that's
interesting.
a little I think I know.
Interesting. Okay. So yeah, we have two types of these disks, like two types of storage. We have HDDs and SSDs. Like now there are tons of laptops that already come with SSDs, but I think HDDs are still like the most common type of disk. And when we're using the cloud, I will say that the well, again, it will depend on your tasks, but the type of disk that you're using, it actually matters. I like if you remember, I told you that for my work, we use these spot spot machines in Google Cloud, where we will just like set up, ask for one small machine, and then it would like that machine dies after the task is done. So we had a lot of tasks with HDD, like they will ask for HDD memory, and I guess that there were tons of input and output operations, so the machines will get preemptive. So like Google will get them back, and the task will have to like start all over again, because those tasks were like they were running for up to like 12 hours without finishing. And once we changed them to SSD, like all the workflow got cheaper, because like even though like SSDs in Google Cloud, and I'm sure like it's the same thing in Amazon, they are more expensive, but the tasks could actually finish before the machines were reclaimed back. So those tasks that were that needed like 12 hours, they were down to like 3 hours or four. So sometimes like the storage type actually matters. Mm, and that's like it's a very small tweak that we can do in our workflows to actually improve them. Mm, but yeah, like it doesn't matter if we have a like a physical machine, because then like we're set up with what it has. Mm, okay, and I mean the other type of processor that we have are GPUs, and it stands for graphical process units, and they are specialized chips that they were initially built for graphics, and now they're usually used for machine learning stuff, and like for Bitcoin mining and all that. They have a lot more cores than our regular machines and our regular laptops, but those cores are not as fast as the ones we have. So those are actually used for that type of tasks that can be like highly parallelized. So the book said that mid-range GPUs go from 700 to 4,000 cores, and those cores run between 1% and 10% of the speed of a CPU core. Mm, yeah, I've never worked with a GPU before. I don't know if you have. Someone else's screen.
I haven't really either, except for a little bit of local LLM work I was doing. And I think it just like new to use the LLM. Like I was using like the R ecosystem for like Elmer and um, some other newer packages, and I think it just new to use my GPU,
Mm,
which is nice, I think.
mm,
And the only other thing I have to say is, I think most like I've seen a lot of folks say that like GPUs are used for graphics, for like video games and rendering, and certain kinds of models like neural nets. One thing I've been excited about, since I don't really do graphics rendering or modeling is the Python polars. Well, I guess the polars API that was originally written for Python and now exists in R and probably other languages. It, I think, is like working to allow for GPU, like to use your GPU for data processing work as opposed to your CPU. I don't know why I would want to do that, like under what workloads it would be beneficial, but I'll copy the link into the chat in case anyone knows more or wants to opine on it.
Thank you. Thanks for sharing your.
Maybe if I'm lucky in a few months, I might be working with a GPU
Nice.
for like a machine learning task. So yeah, I'm both excited and nervous about it. I mean, it's just like I think it's basically I'm going to be running like a speech to text model, so have audio and then produce a transcription. So I think from the programming perspective, it should be just a few lines of code, but it'll be interesting to see how that works or doesn't. We'll see.
Yeah. Yeah, I guess now that everyone is doing machine learning stuff, like GPUs will be more common every day. And yeah, I guess that's also the like the objective, that it shouldn't take that much for the user to be able to use the GPUs. It should be kind of like a more or less transparent a transparent change. But like, yes, we do have to learn all of these new tools. But as Arthur said, like it should be a matter of just like changing a couple of uh, of lines of code. Mm, okay, and
So just one quick thing on GPUs, if you don't mind, is like one thing I wish that existed is sort of like a data scientist buyer's guide for GPUs. I mean, so for me, I guess this would be in like a corporate environment, so it's just a matter of like getting provisioning through IT department. But separately, I'm hoping to buy a new computer at some point in the future, and GPUs are really expensive, and I don't want to spend my hard-won dollars on something that's suboptimal. But anyway, there's just
yeah.
a kind of a wish of something exists. Maybe it's just a matter of finding a knowledgeable party and picking their brain. But I am not that knowledgeable party.
Because, yeah, like how do you? So you get a, if you want a laptop with a GPU, like they will have the normal CPU, and then they will have like an NVIDIA chip with a GPU like addition, right?
Exactly. Yeah. I
Okay.
mean, there are also some things I've seen where you can have a GPU as a separate thing that you plug into your computer. I know Framework, which is like a fairly new hardware maker, they've got some model like that. I'm not sure what the connection is for the GPU, but then I've also seen some like external GPUs that you connect through USB-C. I'm not sure. Some connection to the computer. Uh, but yeah, like the other thing, like for the buyer's guide, is it seems like a lot of this is my vague impression. I don't know if I'm right or wrong on this, but it seems like many of the models are trained on specific brands of GPUs. So I guess for Linux people, this makes life hard, is that the models are trained on using NVIDIA. And then there are lots of famous memes of Linus Torvalds, cursing NVIDIA with certain fingers extended. But it's like AMD is also out there. They've got some good offerings, but then like, is my model going to run with an AMD GPU? These are kind of the points of trepidation for me, which I don't
Yeah.
know. I mean, it's asking too much for the book, but I wish I could find that some guidance in easily consumable form. I mean, if you're provisioning, like this topic of this chapter is like scaling up, like so you can easily get an instance. That's the easy and cheap thing. But if you wanted to do some private at home tinkering, then that's the hard thing, because you buy the thing and you're stuck with it. I mean, you can resell it obviously, but you're stuck with it.
Yeah. Yeah, and I guess it's still like early times for all of these. Like maybe in a couple of years, like they yeah, like you said, like models won't be like that bound to a specific hardware, because like that's how it happened with computers. Like now, I mean, yeah, we can have like Intel chips or the Mac OS chips or AMDs or whatever, and like they all work the same. So I I guess that will also happen with the with the GPUs. Mm, okay, so that's pretty much it for the for the text. The scenarios were in the slides already. I don't know if you wanna discuss something else, or like I wanted to show you and just run the comments in one of the VMs I have running right now. Mm, okay. So I have these two virtual machines in Google Cloud that I'm using. Mm, and this one this one has okay, it's 8 virtual. Okay, I guess this B stands for virtual. 8 virtual CPUs and 32 gigabytes of memory. Like nothing big because they're expensive, and I'm using this with the with like my work is paying for these instances, but I'm using them to finish something from my PhD project. Like we got the comments from the reviewers for my last paper, so I have to finish some analysis. So I was like, okay, our servers got hacked and now I can't access to anything, so I needed some extra computational power. So I was like, okay, I'm gonna do this. So yeah, so it's like, yeah, nothing fancy, but it does the work. Okay, so I'm gonna make this big. And so I have the server here, and we're gonna. I had a Tmux. Um, no, wait. I just forgot how to restore my my
Attach,
session.
tmux attach.
Yes. -A, right? No.
I'm not sure about that one. I'm a tmux noob. I guess you do
Okay.
like a tmux like is it list dash session or something, and you see your sessions.
Yeah, right? Or well, yeah, yeah, we'll remember that later. Okay. So I have a workflow. It's not in R. It's using SnakeMake. So, well, first we can review the comments. Okay, so the book talks about top, but what I don't know what was that. But I don't know who actually uses top, and this H top exists and it has colors and it's just like way better. Sorry, let me.
I guess you
Mm,
only use it if that's what's on the machine. I think that's the thing. Yeah.
if you what? Sorry, Arthur.
If that's what all that you have on the on the server you're connecting to, and you don't have rights to or like much headroom to install new things. Yeah.
Well, yeah, you're right, because yeah, you have to install htop. Then it also talk about aux that will no PSaux that list all the processes. But then if you wanna like kill a specific process, you can just pxaux and then with grep. Find something that you will interested in. Let's see, this interesting. And yeah, you get the PID of the process, and like you can like if you want to kill it, you can then use the kill the kill signal to kill that specific process. Then the book also talk about the F, and that one lists all your disk and how they're being used. In this case, I don't know what Google does and why does it have like that many disks, but this is the disk that I'm using, and like this is the disk that I'm paying for. Like you can yeah, you can ask for a specific disk, and I'm sure it's the same in AWS. And this is not actually your boot disk, it's like an additional disk, and you can attach that one to different instances. You can have like multiple instances using the same disk as at once, but like if you need multiple, if you want to have instances with different number of cores and different like memory, then you can create multiple instances and then attach and detach and reattach the disk as you want, so all of the machines will have access to the same data. That's for the DF. And then for the DU, then that one lists all the again with the minus h, that one lists all the size of the specific files that you have in a folder. And I guess that's everything the book mentioned, right? mm, Okay, so I'm gonna tell you a little bit about the project that I have here. So I as I mentioned before, I work with genomic data. So I have data for different tissues, and I'm comparing normal versus cancer. So I have to do a specific task that is called like calculated mutual information. And to do that, I have a matrix with genes in my rows and all the different samples as my columns. And what mutual information does is that it computes the co-expression or like yeah, co-expression values between two different genes. So this task is actually, it's like I can parallelize that because I only need two different rows in this matrix to get the specific number that I will want as an output. So no, wait, no, I'm sorry, I said that wrong. Okay, no, yeah, I am getting mutual information for pairs of genes, but I I only need my brain is sorry, my brain because yeah, I'm gonna get why is it parallel? Okay, because I only need the information for one gene, and then it will calculate this thing for all pairs of genes. Then I guess I guess I need the transposition of the matrix. You see, that's the hardest part, like thinking about how you're gonna parallelize this. And like this one is it like it's already done. So the result is I get a number for each pair of genes. So I only run it by gene, and then the task calculates the mutual information for one gene versus all of the other ones. So I guess it still needs the entire matrix, but at the end, it's gonna, yes, every task needs the entire matrix, but the calculations is just this one against all the other ones, and then this one against all the rest, and then this one against all the rest. I'm sorry if that was confusing. I should I should have thought about that better. So yeah, all my parallelized tasks need the entire matrix, but it is parallelizable because I'm only calculated this for one gene against all the other ones, then for the next gene against all the rest, and then the next one against all the rest. Is that kind of clear? Kind of?
The
So
subject matter is like not something I'm familiar with at all, but I think I get the gist of it.
okay. Yeah, yeah. Sorry, like, yeah. Just think that I'm just using, like, I'm parallelizing the task by running it gene by gene, using my entire matrix, but only gene by gene. So yeah. Okay. Mm, okay, and I'm gonna run this in a snake make workflow. So I have it here. We're gonna do snake make minus n, and this tells us how many tasks, like the number of tasks that we're gonna have to run. So this says that I only need to run one, like one task, because I'm only asking, like, the way I set up the pipeline for this example. I'm only asking for to calculate all the mutual information, the mutual information results, but only for one specific tissue and one specific matrix. Okay, and with snake make, you can tell the workflow how many threads it can use by task. So I'm gonna show you. So this is the snakemake rules file, and they have this property that's called threads. And if I tell it here that this task is gonna run with only one thread, we're gonna see this in the htop commands. So right now we're just gonna go like single thread. And then we're gonna run this workflow with the, because we're using Singularity that is similar to Docker. I need that Singularity image, and you specify, like with the snake make, you specify the number of threads you want for each task, and then you specify the total number of threads that you have for the entire workflow. So if you have multiple tasks that can be run at the same time, and each task only needs like one thread, and then you tell the workflow that it can run like with, let's say, 4 threads, then it will actually run all those four tasks at the same time. But here, because we're only gonna run one task with one thread, I'm just gonna ask it to use one core. Okay, so now the task is actually starting, and if we check our htop command, this, it was there. uh it, the task there that it was running was there in the beginning. Let's how do we sort by F6? So by the percentage of the CPU. Okay, so this is my task. This is the task that it's running. So you can see here that it's only using one single thread. And because it's doing like multiple calculations on those pairs of genes, like once it's done with one gene, the task dies, and then another task comes again. So the computer knows that it can that it can and that part I don't know how it does it. I don't know how how it selects which core it's gonna use. Because as you can see, like sometimes it's using core 7 and like it jumps from one to another, and then there are the other bunch of tasks that the computer is normally using that they can go to any of the other threads. So okay, let's kill that. Like that's how a usual like workflow in when we're using R. That's how it will look. So now I'm gonna change the threads property here because I only have 8 threads. I'm gonna tell it to use, well, let's ask it to use 5 threads for this task, and uh 5 here because I'm just running one task for the workflow. So now if we go to our htop command, now you can see that it is running 5 different tasks with the same command because it's the same command for all of them, but it's actually different arguments because each of the tasks is being run for a specific gene. So the like yeah the one of the arguments change. I'm Yeah, okay. And I guess when the task die, like yeah, they get removed from htop, and sometimes I can get them because they run like fairly fast. And yeah, like then you can see all the cars going up and down and up and down. And because we only asked for 5 cars, I still have 2 of them, like always, kind of like not running the entire at the entire at the entire percentage. Mm, and yeah, that's how it looks for snake make workflow. mm, and, and yeah, that's pretty much it.
Can you I'm really a Linux noob. Is there a way to filter with top or htop to kind of see certain things? Like I was Googling on the side as you're talking. I know there's the like PS command to see processes, so I didn't know if you could like, I don't know, like FZF on top of like the PS commands and see like just so like there are lots of things going on, right?
Mhm.
And you only care about certain ones of them, maybe. So I was wondering if there's a way that you could somehow see a filtered view of that.
So this one says, okay, with F3 you can search, and like if we want all the Google commands, like I mean it went there. mm,
Ah, interesting. Okay.
but I'm sure that like because the px aux gives you this output. mm, I guess then you can like use grep, like like as or because it also has columns. So if we do I don't know, cut minus f like 3. No, it doesn't work. I thought it will only give us like the third column. Hmm. Hmm. Yeah, I'm not sure. Like with grep you could do like all the searching that you want in terms of the names of the processes, but other than that, I'm not sure what else could we do. And I'm sure like well like here you can sort and that stuff, but I don't know. Let's see what the three three didn't do it that much. Hmm, three again. Okay, no, that's the three. Okay, now we can see the different yeah the different dependencies on the parents and child processes. Oh, that's interesting. And what else? And filter. Yeah, I'm sure there are tons of things we could do. Oh, okay. Filter only yeah, filters the by name. And the sorting. But that's like that's those are the things I will know how to do. But I'm sure there should be a way to like I don't know filter the what would you like to do? Filter by user, filter by
Are,
percentage of use.
are like grep on the command column or something like that?
Yeah, something like that. But I get maybe we'll have to do more with grep than with the h top of the or the other command itself.
But I wonder how it would work is like I don't know how if you can chain those together. Like let's say like you did htop and then you then you use the pipe and piped it to grep to search. Like what would be the end result?
No, because
Would it just be a static table, right?
yeah, no,
Or would that
but
even
for
work?
but Arthur, for that you will use PS outs because
Oh,
PS
okay, okay.
it's the like the lower part of H top and
I
H
see.
just keeps it keeps refreshing
Got
but
it, got it, got it.
the way your processes are running. But with PXAux, then you will do grep on top of PXAux. Like if we don't.
I just dropped in chat this is something I'm just peripherally aware of. So this is another shell, right? Called new shell,
Mhm.
where it seems like the rather than having the things being like standard out, it actually has a table. So
Okay.
it has its own, like own set of utilities where you can more easily do some of the things that require a bit more typing, I guess,
Okay.
like complex one-liners and with core utils. Yeah.
Okay.
There's
Nice.
another one that I need to look into. It's called B-top. So it's an improvement, I guess, even on top of top or H-top. Um, I, I, it looks prettier, but it looks like there's actually maybe some non-aesthetic feature set that might be useful. But again, like
Okay.
the problem is if you don't own the if you don't own the machine and like all you have is top, that's what you got.
Yes. Yeah. And also like well, I guess that there are some people that will actually need this, but it's I don't think it's something that we need that much. Like I usually just need a PXaux when something in my computer, like in my personal computer, something hangs and I want to kill the process. That's my
Yeah.
my usage.
Yeah, no, that's a fair point. I was just thinking like with your thing right here, if you had one process per parallel job, then you could see like which ones have completed, which ones are hanging. I don't know what you'd be able to do with that. I mean, maybe there'd be some like weird thing with the data for a certain row in your data set that I don't know. then you maybe go back and need to rework things. I don't know. That was kind of the thing that sprang to mind. Like if you wanted to see just only the processes you've just executed for with SnakeMake and just see which ones have completed, which ones are hanging, etc. Yeah.
Yeah, no, yeah, that's a good point. But yeah, like I'm sure. Oh, I already killed it. I think I already killed it. But yeah, that will be useful. Okay, thank you. I'm gonna